All right, well, we're going to go ahead and get started here. So welcome to the last session of the day, which is going to be a fireside chat and Q&A session with M3 leaders, Matt Way from Uber, and then Martin Mao and Rob Skillington from Chronosphere. Just a quick overview of how this session is going to be broken out is the first 30 minutes will be a roadmap around roadmap updates and kind of an overview around like open source market landscape for monitoring. And then we'll leave the second half of the session open for just pure Q&A from attendees for Rob, Martin, and Matt.
Awesome. Yeah, so we were hoping to make this kind of a little bit of, more like a panel kind of discussion. Gibbs, if you want to progress next slide. This may be the old deck. See if we could find that again. I'll shoot you this. Is that the one that you have on file? I think we've maybe editing a different one, Gibbs. Apologies. Do you want me to share my screen? I can also do that. If you jumped into the document, I see. While that's coming up, we wanted to kind of talk about generally, I think what we are like what from the Chronosphere and Uber side, where our contributions are centered around right now, and I think like the major point here is that this is a window into things that are top of mind for us. It's not a thing that is necessarily a central focal point of the project in general. It's more just as we like what we as individual contributors to the project are kind of evaluating and looking at, and then of course we wanted to kind of also outline that fact that we're continuing to invest in things surfaced by the community in general. So I guess I just wanted to kind of give that context up front. Martin and Matt, perhaps we could go through some of these and talk a little bit about them. What do you think?
Sounds good.
Great. I mean, I think like the TLDR and like, when Matt and Martin kind of got together to write these like talking points and slides for the chat was like the number one thing that as individual contributors on this project we're most interested in doing is continuing to commit to the investments in the bottom line, as I like to think of it, of the project, which is clustered performance. So a clustered deployment, like really large clustered deployments of M3 get better and better and better. There's some specific things that I've called out here, like for instance, like M3DB bootstrapping improvements, whether that's node joins or DB node restarts. Matt, do you want to talk a little bit about the M3 aggregator?
So at Uber, we have a good number of different, storage policies that all of our metrics fall under. The longest general aggregation window that we deal with, however, is an hour, which means that like our buckets rotate, on the outside of like an hour, and when we bring new nodes online, or if like a node goes down and we have to replace it and things like that, just due to how the aggregator bootstraps currently, it needs to wait for a window to flush before it actually will start accepting writes on like the new peer, which means that like in order for us to recover the cluster if it's in a bad state or to expand rapidly to account for capacity and stuff like that, we're trying to drive down that bootstrapping time for the aggregator. So whether that means things like, seeding from the other node in the shard pair, or, things like that, to just generally improve the speed at which like aggregators are coming online and able to start taking traffic and aggregating the metrics that they're receiving, is one of the operational things that we're trying to drive down, just because it's one of the longer tails in our overall efficiency.
Awesome. Yeah. Yeah, I think definitely, yeah, that kind of underlines like what I guess, we all got together and agreed is always been a very top priority, is like this baseline of being able to do these pretty complicated things at scale, is like the underlying theme there. And so the MV aggregator obviously has some pretty complex features, such as rolling up across dimensions, like doing multi-stage rollups where you apply a transform and then a sum by dimension and then another transform on the other end of it, things like that. So yeah, there's a lot of things. Yeah, there's a lot of effort that goes into kind of like making that base set of use cases kind of operationally operationally easy to use. And then yeah, the further read optimizations and guardrails. I mean, some of the v1.0 limits that were kind of rolled out are a good start there. And there's some things around like us with the reverse index, like basically limiting, kind of like making every query look as big as each other and yielding time between those. That there's some work going on there. So if you're in like a very highly contested environment where you typically see delays because other users are adding significant pressure, you can kind of get like a more interesting, kind of like a more sane amount of like pressure applied equally to all queries happening at the same time, rather than kind of like hotspotting of queries. So yeah, that's some other stuff going on with the cluster performance. Martin, do you want to add anything?
Just to chime in there, like one of the main themes I think all the speakers today talked about was protecting the clusters from varying read loads in various ways. So, this piece of work is to help with that. There are, as Rob mentioned, some limits already in place so that you can protect the DB nodes against various spikes or bad use cases of reads against the DB. There will be continued work there to help with that a little bit. So, hopefully that is one of the pain points that have been called out and we will be addressing fairly soon. And then back to even the M3DB node bootstrapping. So this is another theme that we heard from a lot of the talks today, that actually node bootstraps, which is the process that happens when a new node joins, so it needs to stream a lot of data in from the other nodes in the cluster, or if you're restarting the node, it also has to perform a bunch of operations at the beginning of that. That process does take quite a long time right now. So it is quite a few hours to do that. So you can imagine on a fairly large cluster, even if you're trying to add 5 to 10% capacity, it could take a while to add that type of capacity. And this is one thing here that we saw in some talks today that folks are trying to get well ahead of. We saw in the Databricks talk, I think, trying to map out that 2 weeks in advance so that you can plan for it. Obviously that works for sure, but trying to any improvements we can do there to reduce that bootstrapping speed can really help with a lot of those use cases. So these are already sort of committed investments and ongoing work in these two areas to address what we really found were some fairly large pain points across the whole community right now.
Yeah, and like to that point, M3DB is and the M3DB operator is going to soon be able to add like not you, but yeah, in the past you could do multiple node joins at the same time within a single replica set, but you kind of had to manage that yourself. And so the M3DB operator is now going to natively be able to add like multiple nodes in the same replica set at the same time. So you can like say you want to double your cluster or something like that. If you're adding, say, 15 nodes, 5 for each replica set, 5 can bootstrap all at one time and then move on to 5 in the next replica set. So that way, it's not a function of number of nodes you're adding. It's a function of it's really just it's a function of like how much it takes to add 3 single nodes to your cluster, because at most you could do like each replica all at once. So it would kind of take a max of like 3 node adds to add across the replicas. So stuff like that is obviously is going to be helpful. And like to step back one second there, and the whole reason that we like, it's not trivial to build a data streaming like distributed cluster join process, and folks I think like that are operating clusters that are like in 1, 3, or 5 or nodes of size, that kind of size. What I think like doesn't quite like one thing that I think like isn't easy to kind of see and feel is that without this streaming process in place, you have an imbalance of data that happens as you natively scale up your cluster. So you can end up like, for instance, if you double your cluster from like 10 to 20 or something like that, you will end up with a whole bunch of 10 of your nodes having terabytes and terabytes of data, and the others having almost nothing. So like every other clustered like open source Prometheus use case out there today doesn't do any of this balancing work. And so when you go to query that data as well, now you only have 10 of those 20 nodes actually able to give you back data from the last 90 days, say. Therefore, so you're only using a fraction of your actual capacity for queries. And so really the whole reason there's been such a huge investment in moving data around, it's not just because it enables on-premise. It's actually a large part of it is balancing out the data set so that you can, in a MapReduce fashion, really fairly split the work to do queries that are of significant sizes that kind of touch the whole cluster. So yeah, a lot of which comes back to the theme of like committed investments in large scale workloads that kind of that most folks that are looking at M3 kind of have. It's a self-selecting kind of thing a lot of the time, where folks that want to use M3 usually come from that background, and so we cater very much to that sort of commit. That's where a lot of the committed investments of the project go towards. That might be a good time to look to kind of switch gears to talk about some of this forward-looking work, perhaps. Yeah, I think like there's a lot of, obviously we want to continue to make continue our focus on ease of use. I think M3 was built out first for like a very specific problem, and then over time we've been generalizing to focus on providing a better ease of use across a wider set of deployments. Like Prometheus in general, I think like why that project is so successful in terms of just like the wide usage of it is probably they kind of started, some might say, in the opposite direction, right? Like they're solving one thing and then making it available for every kind of like consumer. Whereas I would say that like in general, one thing that's like clearly obvious between like M3 and other kind of use cases is like it was developed for a pretty deep vertical use case and then has been generalized over time, rather than starting out super generalized over time and kind of adding the scale and depth immediately, perhaps. That's a generalization, but I think like it's something worth considering when you're trying to like think of these conceptually on the landscape of things that are out there. And it kind of like, like Kafka at LinkedIn is a pain to use, like from LinkedIn was a pain at the beginning to use, but like, and got generalized over time to the point of Kafka is like the only thing you would really, is mostly what everyone, goes to use at any kind of real level of scale for a pub sub. So, that's just, again, kind of drawing a correlation in a very generalized way, and I wouldn't read too much into it. But I think like conceptually, when you break down the systems, that's generally one way of thinking about it. Matt, do you want to add any more to that?
No, I think that makes sense. I mean, in general, the forward-looking work that we're thinking about is, as you said, like focused on solving a lot of the just streamlining of the way that everything works. I think, when we look at things through the lens of like Uber's scale, for example, like I think it helps us understand like how many more potential use cases we could be solving for, just given, volume of data. So to that end, like I think there's some things that would be good for us to tackle at some point, like improving. So like, in infrastructures where you may not have as much control over your data flow, and like out of order metrics are a bigger deal, or like you need cold writes, or like you have to, support like data tiering and stuff like that. Like those types of things I think are, ways in which we can, continue to also support more use cases, potentially also larger volume use cases. So, yeah.
Cool. Martin, any other comments?
No, not much there. Just I don't know if we caught out the second one here in particular. There's been some interest, I think, from the broader community about some of these large data analytical type of use cases. So, if you already have a lot of your metric data stored, excuse me, for a long period of time inside M3, perhaps why would you want to replicate that to a different system, just so that it can be used by large data tools like Presto and Spark. Following up on some work that was done here, in fact, that work wasn't super specific to M3, but there is a Prometheus Presto connector that is available out there that will allow you to use SQL-like queries for these large data analytical use cases against Prometheus-based backend systems, including M3, such that you can choose a time series database for your metrics monitoring data like M3, and not have to replicate that data, but also make that data available in your large data use cases. So you can easily do joins using Presto across multiple data sets. Some can be SQL, some can be NoSQL, some can be time series like M3. So that work is already somewhat enabled, and just to call upon some follow-ups we're expecting in that area as well, because that has been a common theme of questions that we've been getting inbound.
Yep. Yeah, definitely. I think like the Presto use case is super interesting. Folks want to do more analytical things with it. We obviously gave a talk from Chronosphere at KubeCon recently on that. I would recommend checking that out if you're interested in it at all. Right now it works by querying the Prometheus HTTP API. We didn't work on this piece of infrastructure, by the way. This is just something that we noticed that was, I think, like kind of underutilized out there in the community. Would love to also use Spark with like similarly to like do kind of like distributed queries on top of Prometheus data. And it's obviously something that the community is interested in as well. So yeah, would love to make some more progress on making it generally kind of like easy to use, accessible, and more kind of like vanilla, like just kind of accessible and very like standard to be able to deploy and run. Obviously, most of that work there is just with the Prometheus protocol and Spark and Presto itself, and nothing really to do with M3. But I think it's like something that we'd like to make sure is a first-class experience as that kind of story gets built out in general. Yeah, cool. Gives you, I guess, Matt and Martin, unless we have anything more, we can move on to the landscape, perhaps. Great. Awesome. So, sorry, Gibbs, just remind us how much more time do we have before Q&A?
You have another like 8 to 10 minutes.
Okay, great. Yeah, Martin, do you want to walk through like?
Yeah, I can definitely do this. So, a common question I guess we get from the community and people looking at M3 is where does M3 fit in the landscape, in the broader monitoring open source landscape, but also in particular in the Prometheus ecosystem. Where does it fit and how does it sort of compare? So we figured we can spend a little bit of time just to give our thoughts on this today, and perhaps answer some of those questions ahead of time, because it seems to be questions we get a lot repeatedly. So, the first part of this, I think, is looking at the broader landscape of popular open source monitoring tools. I think this has really evolved over the years. So, even at Uber at the beginning, quite a few years ago, Graphite was really the main sort of open source solution out there that the whole community was using. Over the years, that perhaps evolved into some other solutions in between, like Influx, for example, was a very popular backend solution for time series data. But really in the most recent, probably 3 to 4 years, especially with the rise in popularity of Kubernetes and the cloud native ecosystem, Prometheus has really become the sort of de facto standard in terms of open source monitoring, and that definitely makes a lot of sense. It comes out of the box, a single binary solution that does do ingestion, storage, alerting, and actually has its own visualizations embedded in it as well. So it is something that was designed to be very easy to use, and was also tag based from the beginning, which is quite different from Graphite. And I think that tagging scheme works well in the sort of modern cloud native Kubernetes ecosystem. So, that's a sort of evolution that we're seeing. And at the same time, we're sort of building M3 while sort of the Prometheus project was becoming sort of popular there. And really what we're seeing was a growing set of Prometheus use cases, both in the community as we're building M3, as well as inside Uber itself as well. So, from the M3 perspective, this is quite a few years ago, we didn't really want to continue to shard the broader open source community in any way. And really we could see that the direction of the community was moving towards Prometheus, especially from an instrumentation perspective. So the decision was made quite a while ago to make M3 compatible with Prometheus, and to sort of have M3 solve perhaps some of the pain points that Prometheus did have. So, a lot of the challenges of Prometheus were called out in various talks earlier today, things like replication in the HA mode, and perhaps how difficult that is to deal with. The fact that it's sort of mostly vertical scale is the way you would scale up, as opposed to horizontal scale. So these are actually properties that, M3 were really nicely designed to solve in the first place. So sort of complementing the two things together seemed to make sense. And actually, Prometheus allows other solutions to do this quite easily using the remote read and write APIs, right? So I think the Prometheus community understood that there were limitations of their technology, and rather than try to solve them in their existing tech, they sort of exposed APIs for other solutions out there to go and implement, to go fill in some of the gaps in their replication and scale side of the story. So, this is how M3 today integrates with Prometheus, is via the remote write and remote read APIs. M3, along with other sort of remote storage options for Prometheus, implement the same interface and sort of play a similar role there. So one thing that's a little bit different about M3 to some of the other projects there is that we actually generally don't recommend folks going through the remote read API. And this is why we built a query engine inside M3, because there are particular things we can do in a query engine if it's been optimized for the storage tier. So the M3 query engine has been optimized for how data is stored inside M3DB itself. And if you can take advantage of those optimizations, it means you can execute queries far more efficiently than using Prometheus to execute the queries. And a lot of this has to do with decompressing all of the data before feeding it back into Prometheus, whereas in M3 we can keep the data compressed. You can imagine lower network throughput on the reads, and actually lower in-memory usage as well to execute those. So that's probably the one thing that M3 does a little bit differently as a remote storage, is that it actually just exposes both Prom and Graphite query endpoints directly for you to hit, as opposed to having to run Prometheus to do your queries, or having to run Graphite or Graphite Web to do your queries for that path. Looking a little bit more at the sort of other options in the Prometheus ecosystem, and probably the three most popular remote storages that we come across all the time is Thanos, Cortex, and M3. And we commonly get asked questions on, hey, how are they different? Which one should I use? I don't know if there is a clear answer here, so I thought I might just go through some of the differences about them, and some things to keep in mind as you make that decision, and how these projects came to be where they are today. So if you look at Thanos, it is S3 backed storage, so all of the data for long-term retention is stored in S3. It does integrate very well with Prometheus in the sense that it actually depends on Prometheus instances for the most recent data. And then, of course, for more historical data, you do store that into S3. So it's a great solution, especially if you care about the cost of your storage, because S3 is extremely cheap these days. So the trade-off there is probably lower cost on storage versus, obviously fetching data from S3 versus the local disk is going to be a little bit slower. So there is a bit of a read performance and storage cost. It is also fairly easy to manage, because you're not having to manage the stateful storage component yourself. You're really depending on the cloud provider and AWS in particular with S3 to handle all of the complexities of storage there, and the replication and the reliability components. Cortex is a little bit similar that way. There are definitely various backends you can use to store your time series data in Cortex. For example, Bigtable is one. You can use that as a backend for Cortex. You can use Cassandra, either hosted, or you can run Cassandra yourself, or you can use S3 as well. So again, very similar to Thanos in the sense that there are different backend options, and you can actually have a cloud provider go and manage them for you if you don't want to manage it yourself. So that is definitely a plus. There are some using those solutions, especially sort of key value or object store solutions to store this data, comes at particular trade-offs. And in some of the talks earlier today, we heard about some of the cardinality issues in particular, perhaps at scale, that you may run into, and that is the sort of side effect of what you get when you make that trade-off. The other feedback we've heard from some folks about the Cortex tier is that there are a lot more moving parts, about 9 components that you sort of have to run. So it is more pieces of tech that you have to keep an eye on and manage yourself is probably a big difference there as well. And then again, for M3, as we talked about at the beginning of the day, it's really been optimized for scale and performance. This is why we made those decisions to implement the DB ourselves, and for folks to run the DB themselves. There's really not a way of getting around that at a particular scale. You sort of have to not use the less optimized technologies for it. So you're using a key value store versus a time series database. That's sort of applying the wrong type of solution or technology to the problem. With M3, the other thing there is that it is relatively simple in terms of architecture. There's really only 3 main components, and each one does scale horizontally by itself. Of course, the downside is that you are managing your own stateful database nodes, and that does come with additional management overhead for sure. We do try to help with that with things like the Kubernetes operator to make it as easy as possible. But of course, everything comes with particular trade-offs. And I think if you look at how the decisions that were made and how these projects got to where they are today, I'd say it's probably 2 different approaches from the Thanos Cortex perspective and from the M3 perspective. From the M3 perspective, because of the scale that we had to solve for inside Uber, we really had to solve the stateful storage problem first. There was actually a previous generation of M3 that was built on Cassandra, and it just couldn't scale beyond a certain point. So, following the footsteps of other tech companies like Google and Facebook, we really had to go build our own time series database to sort of solve that scale and performance problem. And really the focus was on solving that piece first, and then sort of optimizing for the ease of use stuff later on. So things like the Kubernetes operator came a little bit later on. And that is part of the focus moving forward for the community, is how can we continue to make the ease of use easier for M3, but solving the hard stateful problems first. Whereas perhaps if you looked at some of the other projects like Cortex and Thanos, they started with the ease of use stuff first by relying on the cloud providers to take care of the stateful storage components. So relying on other technologies there. And then sort of, coming back around later on to start to optimize for some of these problems today. So just sort of different approaches to the problem. I don't know if there or think there is one correct or incorrect approach. It's just how these projects sort of came together and why the focuses are different depending on the phase of the project per se. And then the only other thing, and I've been rambling on for a while now, so I'll let Matt and Rob chime in as well, but the only other thing I sort of proactively call out a little bit, we also get a lot of questions on whether we would ever consider putting long-term storage for M3 onto an object store like S3. It's actually something we've been thinking about for quite a while. In fact, when we first designed the storage API layer, we actually made it fairly generic such that you didn't have to use local disk in the file system to be your only way of storing historical data. I think that has never, that idea and actually implementing that hasn't ever been something we put a lot of effort into, because if you look at today a cluster of M3 at scale, really a lot of the costs go into the compute side of things. So CPU and memory chews up a lot of the costs. And if you look at the actual underlying storage costs, for most clusters we see out there, it's relatively small. It's like maybe 10 to 20% of the cost is on storage. So, a lot of our work historically on the performance and cost efficiency side have been to optimize for what costs the most for people running this in open source. And that has been the compute and the memory side of things, and not historically been optimizing for storage, because we get less bang for buck from those investments. So, that's a common question that we get asked, and, I want to proactively call that out and say why we haven't sort of put any effort into that yet. Could be something in the future for sure, if we continue to crank out, improvements in compute and memory, and we see that storage is now the bottleneck in terms of cost. Perhaps that would be a good time to sort of look at that type of solution. But thus far, that's sort of the reasons why there hasn't been a lot of focus there. But I will stop rambling and hand it back to Rob and Matt to see if they want to add anything to that.
Yeah, just really quickly to chime in there. Yeah, and I think projects have trade-offs, right? And definitely we, as Martin said, are looking at the most painful thing and optimizing that first. And then secondary, the other trade-off is just that, if you look at Thanos and Cortex, when you run a query back, a 90-day query, the one trade-off that we've made that to focus on other areas now also has the other interesting trade-off is that that is all that data is mapped into M3DB, and so and we've run definitely various tests on this. You don't hit tens of seconds to go and fetch all that data if it's a kind of as long as you're not obviously grabbing back millions of time series at once, and you're kind of got a normal sized query in terms of time series that you're reading back, you can get 90 days queries completing very quickly in M3 because it's all mapped, it's all on disk local to the nodes, and it can go fetch it for you fairly quickly. Whereas with things that have to be pulled out of object storage, there's caching and there's all this other stuff that's going on. But if you want to do an ad hoc query of you're exploring the data set, that's going to be, you're going to have fairly linear performance from M3, and it's a trade-off. Sometimes that will matter to some people, it'll matter less to others, but that's a trade-off that's been made in the current short term. So it's not it's not a black or white type of image you could to look at there, and I think it's just one thing worth noting. Matt, did you want to add any more 2 cents before we open up the Q&A?
I agree with everything you just said. I guess the one additional thing I throw out is it is a lot easier to start with performance and then improve ease of use than to go the other way around. And especially as we're seeing Kube stuff improve, and I can imagine just the swath of additional tooling that will improve and invent over the next coming months and years. I feel much more confident in the direction that we're going versus like having to go, you know, the other way around.
100% Matt, but I feel like we are biased in that, so I didn't want to say one way.
Yeah.
But, yeah.
There's trade-offs, and that's the trade-off that we've made. That yeah, we're the path we're trotting down. Anyway, yeah, Gibbs, yeah, would love to, and I would love to hear for the questions everyone has.
Yeah, so for everyone that's on, same as all the previous sessions, we will be handling the Q&A through the Q&A box in your Zoom, on your Zoom chat window. So the Q&A icon. So yeah, so the rest of this session is dedicated for that. So feel free to drop your questions in there and we'll make sure to get them answered.
Cool. First question here. Maybe I'll read it out for you, Rob. Maybe you could take this one. What is the roadmap for cold writes, reverse index, and aggregator?
Yeah, interesting question. So as we kind of went through that like roadmap slide, I think like there's the like major focus of the project really continues to be like the basics, getting better and better. In terms of like things like cold writes, so cold writes works today. It's just simply that the reverse index doesn't index data in the past. So you can turn on the feature and write things into the past, just obviously, and I'm assuming, Saf, you already kind of know this, but yeah, they will not get indexed. So you can't query for it if it's a new time series relative to that block that you're writing to. And so, yeah, I guess we're still kind of like waiting to hear from the community what they like. A lot of the issues that we work through, obviously, are as we kind of like, you know, kind of covered in previous sessions, are like we have large end users that like have a really sore point, and we kind of like listen to that, and if we hear the same thing over and over again, then we kind of work on it. And so with cold writes, you know, it's I guess like one thing that like definitely is, it's not like it hasn't been raised. It's not like folks wouldn't like to have it. It's just like in terms of like the priority bucketing list, there's been rarely times where it's been like the thing at the top of the bucket, and so that's kind of like the status of it, as you've seen in terms of development. Like it hasn't been high at the bucket of like inbound noise, so we haven't been like rising into the bucket of time spent on stuff for the community when we go and have time to spend on writing stuff for the community. So yeah, as of now, like there's obviously good foundations out there, but you know, I really don't know about, yeah, like if there's like a committed timeline or anything like that, or even if it starts to rise to the top of the noisy bucket, I think that's the right time to talk about like what it looks like for cold writes in general. Martin, do you
Yeah,
have
I was just going to add some context there. I'd say, you know, if you look at most of the use cases of M3, it's generally behind Prometheus. There generally isn't like a Kafka pipeline in between or anything like that. And if you look at that general inbound flow, the amount of use cases where data comes in extremely late, and, you know, just to give other folks on the call a little bit of context here, M3 can handle out of order writes for a set buffer time. You can set that buffer time to whatever you want, 5 minutes, an hour, and whatnot. And if you have any data in that time, it would successfully write it. Outside of that time, it will drop the data on the ground. So the cold writes feature was originally designed for those writes outside of that buffer, still eventually store them and index those data points. I think that most of the use cases of M3 that we see in the open source community, especially with Prometheus these days, there really isn't too many use cases where there is a more than a multi-minute delay in the ingestion pipeline, because most people do not use, let's say, something like Kafka in the ingestion pipeline to replay historical data. And because of that, it's probably why a lot of people don't necessarily need that feature, because the buffer period is sort of enough. And then Matt, I don't know if you wanted to chime in here a little bit about this. I feel like perhaps this is something that Uber gets around in one way or another as well.
Yeah, so on our side, we tend to deal more with out of order metrics than cold writes, just because like we fully embrace like the sort of like real time, design nature of like M3 as a platform. So like for us, improving the efficiency of out of order like encoder merges and stuff like that is something that like is pretty high priority, just because like we can't always control the order sometimes. That being said, I think it's sort of like you both are alluding to, where it's like if the community feels that like this is a large enough like pain point and there are enough like supportive use cases to like buttoning up cold writes and stuff like that, I think that is something that can make sense. We just don't generally have that kind of use case on our end, because like again, like it's all real time within Uber.
Cool. And I guess the aggregator was the other thing that was there. I don't know, Asaf, if you have a specific question about the aggregator. I think like all of us would love to see the config get trimmed down a bit. It's probably as bad, if not worse, than when like when N3DB itself was just open source and had kind of like the huge kaleidoscope of config without any defaults really available. Like you kind of had to, the defaults were the example config rather than like it kind of like automatically being set for you, which they like now you can actually launch a database with a 2-line YAML config, which is literally just says, I want the coordinator, I want the database. So the aggregator needs to go through that kind of evolution where it gets cleaned up and like kind of more consumable for like kind of for folks that like aren't well acquainted with like the example configuration and what everything means in there. And when we're going to do that, I think it's like the same thing. It needs to rise to the top of the noisy bucket. But yeah, that's so like yeah. We should talk about it more on the on N3 Slack. Backfilling supported. Who wants to take a first stab at this? I can, but Martin, you can as well.
Yeah, I can have a look at. Yeah, I can take this one. So yeah, this is something. Again, maybe a similar answer here, but backfilling probably is something that a few people have asked about. I assume this is to import massive amounts of historical data from another system into M3. This is a little bit different to the cold writes. You can imagine perhaps you could do this using the cold writes feature because you're writing historical data. This is a little bit different because the cold writes feature was designed to occasionally insert some data into the past, not be used to completely rewrite all of history. This is again one of these things that have never popped up to the top of the urgent need perspective, mostly probably because a lot of the use cases we see of M3 are people graduating from Prometheus, and generally in Prometheus, you don't have the ability to store years of historical data there. Most folks store maybe a week or 2 weeks worth of data. So the common use case we see is that people spin up M3, they will just write data into M3 for 2 weeks before going live, and then they have all the historical data there. So it's probably the reason why this hasn't made it to the top of the list. And I would say even if and when it does, I would have to come up with a fairly different strategy to do much larger imports of data because the original cold writes feature and what is there today isn't really designed to do this type of use case where you're really writing, I imagine perhaps years worth of data there. So yeah, I think the best bet right now is to dual emit between your old and your new system. And that could perhaps be a way to get around it. The other way, maybe if this was really critical, everything is open source, so you can see how files are written onto disk. I can imagine you could perhaps write something or take parts of the code to go create what the files would look like on disk yourself, and then just have them, SCP those files onto the nodes and run that way as well. So it could be a DIY solution as well.
Yeah, we've been wanting to spend some time to make that DIY type of thing a little bit easier. Like there's actually tools in the source tree that go and like read out data blocks. It'd be fairly trivial to, as Martin alluded to, like add tools to write out the data blocks and then kind of like put them in the right places. So yeah, they're under M3 source CMD tools. There's a lot of like reading tools here, verification tools, M3CTL, which Brian at LinkedIn wrote. So there's like all these various files, tool set. It'd be pretty straightforward to add one to write files. But again, like that's, yeah, probably the fastest way that becomes available is like someone contributes it. Yeah, just that's probably, that's that.
Cool. I can take the next question that we have. So there was a question about, are you considering implementing a process like Kip and Kafka? So things like design documents, tracking issues, getting more community involvement. One of the things that we have talked a lot about recently since hitting 1.0 and in preparation of hitting 1.0 is how we deal with like proposals and design documents and things like that moving forward. So full disclosure, like this is something that we're still sort of like debating some of the nuance around and like how like formal and like detailed and sort of like, complex the process will need to be like in the future. But for now, we have this repository. It's m3db/proposal. This was originally created as a place for us to track issues against like m3db sort of like as an overarching platform. And looks like Rob's got it pulled up there. So this is something that we probably should be doing a better job socializing, as just communicating to folks that like this is a place where you can go to create issues just about like the M3 technology, not necessarily an issue against like code, like bugs and stuff like that. This process right now, I think is at least something that can get us to the place where we're able to collaborate more broadly, like together as a community, whether or not like we sort of like fold this into like, the M3 monorepo, or whether we go with like another process entirely. I think, time and sort of like feedback will tell, right? But like for now, we absolutely welcome ideas, proposals, suggestions, things like that. And you can certainly create an issue on the proposal repository. If you create one on the M3 repository, we'll ask you to like create a more sort of like high level or broader one in the proposal one if it's in depth enough or something like that. But I guess the thing I'd ask is like just bear with us while we try and figure out like the right long-term process. But for now, we absolutely want your feedback and to be tracking these things and to figure out how they fit into the roadmap relative to just overall project priority. I don't know, Rob, Martin, anything else you guys want to add there?
Not much. Yeah, man.
No, I think you hit it straight on. That proposals is probably the best way to go formally. Of course, Slack channel, we're on that channel as well. You can always just bring up things there as well. So.
Yes, lots of distributed databases have cap and memory, flush based on size, and then compact later. What was the motivation? Basically, for a time-based time-based windowing, I'm assuming, is the is what's kind of brought up here. Especially because memory is pricey. So I mean, I think like one thing that we saw a lot of with other distributed databases we were using, like Cassandra, was that compactions is a massive usage of resources, both disk, like for instance, we would run Cassandra clusters with 50, 70, hundreds of nodes, the disk size would be like 1 terabyte. You would be able to use about 500 gigabytes of that 1 terabyte before it starts doing a compaction of 300 gigabytes in size or larger sometimes. And so you just play this like this game of fire with like, how much disk do you have? Is it elastic enough to support your compactions? Are compactions kicking in while the cluster is also getting hot? And so one of the original design goals of N3 was avoid compactions wherever possible. And so that has, and then if you look at workloads like Databricks, and like a lot of other workloads as well, the amount that you read can be really, really high. And if you're reading like 200K of like 1 million data points you're writing in, like that kind of order of magnitude of the data set that you're actually writing in. If a large majority of that's coming from disk every time you query that every 30, 60 seconds, like that's the amount that you're going to thrash the disk, and just the resources in general is huge. So we just generally found that honestly for real-time time series monitoring workloads, it was better to align based on time and to make everything immutable past a certain window so that we wouldn't like have to do compactions. Now, like, would it be interesting to, and like if you really have a truly crazy high cardinality workload where you're seeing memory bloat because you have a whole bunch of stuff in there that you don't read back regularly, my advice would be to choose a smaller block size. It's gonna like that's gonna result in worse TSZ compression, but it will obviously evacuate memory faster for you. And if you like most of your monitoring queries only look back like 10 or 30 minutes, then you could definitely shrink your block size from the default 2 hour down considerably if you wanted to. But that is something that you have to go and choose to do and configure yourself, obviously. So it's not like automatically adjusting to a workload or anything like that. But yeah, that is the major reason why it is how it is, and the recommended pathways to kind of configure and optimize if you're finding that you're putting a whole bunch of things in memory that you're not reading back. Matt, do you have anything to add?
Yeah, a couple things. I think you made some great points. So some of the things that we've learned based on like the workloads that we see at Uber, for example, specifically related to the cardinality, are that some of the solution may lie in sort of like waste management and things like that we don't necessarily have like automatic control over right now. So for example, some of the things that we're experimenting right now, and we'll see the extent to which they're effective and maybe we push those out, but are things like understanding what of the things that have been written are actually being read, and like doing unmapping or just like purging or things like that to try and like reduce like bloat in the data store, just because like again you work at a large company that has a lot of engineers and you're not going to have 100% like utilization of your data, so just trying to like find some of those places where there's room for resource efficiency is good. The other thing is too that like I think you can't, in our experience, you can't really double dip on resources, unless you have really good resource isolation. You're going to end up trying to double dip on like your memory and CPU for, as Rob mentioned, like doing very expensive compactions while you're also trying to handle like potentially aggressive workloads. And it's difficult to, spare the capacity that you need on either side of that fence to sort of like keep above water without necessarily, circling the drain, as it were. And then I guess like, lastly, the just the idea that overall we found that the how to put it, it's just been easier for us to manage the back pressure of the system as a function of like being more resource conscious on the right side, whether that's memory or CPU, than if we were doing something in which there was also additional sort of like background resource utilization. So applying back pressure sort of like from the front instead of like doing it sort of like as a bladed thing and potentially running into over resource consumption. Also, disk thrashing is like a huge issue for us, and like the number of disks that we have to replace on like a regular basis is like non-trivial. So trying to minimize the amount of like disk usage is also important.
Awesome. And actually, this one would be interesting to hear any updates from your side, Matt. But I think like in general, repair was I would consider it for the metrics and monitoring use case as prototypical. I know that at Uber, repair runs on some non-metrics workloads, I believe, Matt. But and I'll let you speak to that. In terms of like its availability and like use in in like the open source like Prometheus world. Prometheus metrics world. It's I would call prototypical. I definitely wouldn't advise super jumping into it. And it's similar to all those other things, right? Like when it's noisy at the top of the center, we could potentially look at it. It is